We are going to look at the determinant of a matrix. This is going to be a process that we do to a matrix that is going to give us information about the matrix or the system of equations that we are working with. A determinant of a matrix is only defined for a square matrix. This is going to be some matrix that is n by n, where the row and the column are both matching. So for instance, a 2 by 2 matrix would have a determinant defined for it, but a 2 by 3 does not have a determinant defined for it. So this is defined, and this one's undefined for these determinants. If a determinant turns out to have a value of 0, it has a special name. We call this singular. If a determinant is evaluated to be 1, then it is unimodular. Before we actually get to the calculation, I want to talk about some notation. If we start out with some given matrix with entries A, B, C, and D, then we could write DET in front of this matrix to say that we are going to take the determinant of this matrix. Another way that we could notate that we are using a determinant is to put a single line without the brackets with the same entries inside. So determinant of the matrix is equivalent to this array that has what appears to be an absolute value bar around it. We will now look at the definition of a second order determinant. This is the determinant specifically for 2 by 2 matrices. We have this formula approach to it. If we take the determinant of this matrix with these elements as entries, then we multiply along the diagonal here and subtract the product of the diagonal going from the opposite corner. So we have A times D minus B times C. And this will be a number. If these are real entries, this will be a real number. And so the determinant of a matrix will be a single number. Let's take a look at an example. Looking at this example matrix, we have entries 2, 3, 5, and 8. We want to multiply along this diagonal starting in the upper left-hand corner. So I have 2 times 8, and from that we are going to subtract the product of the diagonal in the opposite direction, starting in the upper right-hand corner, 3 times 5. So this is going to give us 16 minus 15, and this will be 1. So this matrix, if we take the determinant of it, will be unimodular. It has a result of 1 when we apply this definition. Looking at the third order determinant, this is going to be the determinant of a 3 by 3 matrix. I've started to fill in the process, but I'm going to complete it as we go through this. I want the determinant of a 3 by 3, so I've rewritten this with the vertical bars here. I've copied all the entries. The first step that we are going to do in this process for finding this determinant is we are going to copy the first two columns on the right-hand side of this bar. This is going to allow us the extensions that we need so that when we look at diagonals like we did in the 2x2, we can cross through and see the diagonals in a straight line. So starting up here in the top left-hand corner, once again, we are going to look at the diagonal here. So this diagonal here is going to be a product A times E times J. And then we are going to go to the next letter on the top row and look at the diagonal here. This is going to be added together. So we're adding these products together. B times F times G. And then we're going to go over here to the third column and look at the diagonal here. C, D, H. That will be added in with this product. Similar to what we did with the 2x2 matrix, we are going to go to the far right-hand corner inside the matrix here, and we are going to look at the diagonal in the opposite direction. So the first product that we will have is C times E times G. And to that, we will add the next diagonal, coming over here, A, F, H. And then lastly, B, D, J. Each of these will again yield some real number. The sum of these products will be some real number I will call R sub 1, and the sum of these products will be some other real number I will denote R sub 2. Now that's assuming that these are real number entries. What we are going to do now is to finalize this determinant, we are going to take these two numbers and subtract them just like we did in our 2x2. So the determinant of this will be R sub 1 minus R sub 2. And again, if these are real numbers, we're just doing subtractions, so the result will be some other real number as our determinant. And again, we take the determinant of a matrix, we will get a single real number. Let's take a look at finding the determinant of this example matrix. The first thing that I want to do is copy the first two columns on the outside. The next thing that I'm going to do is I'm going to go to the upper left-hand corner and look at the diagonals and find products. I want 0 times 2 times 1. To that, I'm going to add the next diagonal, 1 times 8 times 5. And to that, I'm going to add this last diagonal, 3 times 4 times 3. And then we can look at what this turns out to be and get an actual number. This first product is going to be 0. The second product is going to be 40. And this third product is going to be 36. Giving us a sum of 76. The next thing that I want to do is I want to look at the diagonals going the other way, starting with the upper right-hand corner. So I want the product of 3 times 2 times 5. To that, I'm going to add 0 times 8 times 3. And to that, I'm going to add 1 times 4 times 1. Again, I'm going to simplify this so that I get one single number. 3 times 2 is 6 times 5 is 30. 0 times 8 times 3 is 0. And then we're adding to that 1 times 4 times 1, which is 4. So I have a total of 34. Lastly, we are going to take 76 and subtract the 34 from it. And this number will be the third order determinant of our 3 by 3 matrix. So 42 is the determinant of the matrix that we started with. Cheerful calculations.